So for this practice problem, we are finding the limit as x goes to positive infinity of e to the 2 over x minus 1 over 4 over x. And I just want to remind you of a limit that we already know. We know the limit as x goes to infinity of any constant over x to a positive power is going to equal 0. So when I'm using direct substitution for this problem, I know that that 2 over x is going to go to 0. And this 4 over x is going to go to 0. And e to the 0 power is 1. So I'll have 0 over 0. So because I have the indeterminate form of 0 over 0, I can use L'Hopital's rule. So I'm going to start over here. And the first thing I'm going to do is rewrite this to make finding the derivative a little bit easier. So, and this is just a preference. I'm going to write this as e raised to the 2x to the negative 1 power over 4x to the negative 1. And now when I apply L'Hopital's rule, I'll have the limit as x goes to positive infinity. I'm going to use the chain rule here, so e to the x is e to the x, so when I take this derivative, I will first have e raised to the 2x to the negative 1 power, and then I need to take the derivative of the inside function, so I'm going to take the derivative of 2x to the negative 1. So I'll drop that negative 1 down in front, decrease it by 1. And then the derivative of negative 1 is 0. In the denominator, it's a power rule. Drop down the negative 1, decrease it by 1. Now I don't want to look at it this way. I want to put it back as a fraction. So I'll have e to the 2 over x. I'm going to bring that negative 2 all the way out in front and write this over x squared. And then in the denominator, I'll have negative 4 over x squared. Now, I can simplify this. So I'm going to bring this up kind of right over here. So I've got complex fractions. So this is the same as if I've got negative 2e to the 2 over x squared times x squared over negative 4. So those x squareds are going to cancel. The negative 2 and the negative 4 can simplify, and I will have the limit as x goes to positive infinity of e to the 2x over x over 2. So again, we know that the limit as x goes to positive infinity of that 2 over x is 0. So when I use direct substitution again, I'll have e to the 0 power over 2, and e to the 0 power is 1, giving me an answer of 1/2.